Find the eigenvalues and eigenvectors of the matrix below. Matrix is 4, 14, 3, 5. So pause the video, write it down, and go ahead and try. Okay, you're finished? What did you get? Alright, so remember now, let's discuss the theory behind it. Eigen is German for own. So you're finding the vector, the matrix's own values and its own vector. Here's a formula. The matrix, usually represented by A, multiplied by its eigenvector, its own vector, is equal to the matrix, is equal to the value of the matrix, its eigenvalue, its own value, multiplied by the vector, its own vector. So you could replace the matrix itself by its value. Now if you subtract both sides, A times V minus lambda V is equal to 0, and factor out the eigenvector V, the matrix minus its value equals 0. But then the matrix itself, would be in the form A, B, C, D, just like the one you have up here, minus a single number lambda. That can't work. You cannot have a matrix minus one number. So what you have to do, turn this into a matrix, multiply the number by the unit matrix 1001. Alright. So what you're going to end up with is lambda multiply what you have here. So this will become lambda 0, 0, lambda. So therefore, this must be multiplied by the unit matrix, which is the identity matrix I. See that? So let's go. The thing is, you see this as it is here? If you should try to find out what is V, one thing you can do is find the inverse of this matrix. It will end up as a matrix. So A minus lambda I inverse times A minus lambda I times V is equal to, you multiply both sides by the inverse of A minus lambda I times 0. And by the way, V is a vector which is written as a column matrix in the form X, Y. Right? Now, here, what we have is that A minus lambda I inverse times A minus lambda I will give you the identity matrix, which would be 1001. Alright, let's write it in that form. It will give you 1001, 2 by 2 matrix, since what we have up here is a 2 by 2 matrix, times the eigenvector equal the inverse of it, whatever it is, times 0. But when you multiply by 0, it will be 0. Right? Now, what you would be saying is that the vector, let's write it in the form xy, you would be saying that the vector would be 0, right? The form of that vector is equal to 0. So x equals 0 and y equals 0. But that cannot work. The eigenvector is not 0. So therefore, you should not be able to find the inverse of this. So it is a singular matrix. Alright? And what is the determinant of a singular matrix? The determinant of a singular matrix is equal to 0. Right? So, here now, let's work with it as it is. Determinant of this is equal to 0. You're supposed to get 0 when you do that. Now, A is 414.35. 414.35 minus lambda times 1001. The determinant of that equals 0. But when you multiply lambda times all of this, what you get is that this one will be multiplied by lambda. The zeros times lambda is 0, they remain 0, and the 1 times lambda is lambda. Alright? So, what you have here, let me get rid of this point, I don't know where it comes from. What you have here is 4 minus lambda, 14 minus 0, which is 14, 3 minus 0, which is 3, 5 minus lambda. The determinant of that is equal to 0. Alright? Now, 4 minus lambda, remember, determinant is these multiplied minus these multiplied. Alright? 4 minus lambda times 5 minus lambda minus 14 by 3 equals 0. So, multiply them out. 4 by 5, 20 minus 4 lambda minus 5 lambda plus lambda squared minus 14 by 3 is what? 3 4 is 12. Bring down the 2, carry 1, 3 1 3 1 4 minus 42 equals 0. Alright? So the lambda squared, let's put it here, lambda squared minus 4 lambda minus 5 lambda gives a minus 9 lambda. 20 minus 42, 20 minus 42, that would be what? 22, negative 22 equals 0. So you see that? Now, let's see something here. Can this be factorized? If we can't factorize it, we should have to use another method. Let's see now. Can it be factorized? Let's see. 11. You find two numbers that multiply to give 22 and add to give 9. 11, 2, 22 and 1, 11 and 2. Can't find anymore. Alright, we just have to use the formula then. So, lambda equal 9 plus or minus the square root of 9 squared, 81. We could have used thing there too, you know. completing the square. You could have used completing the square too. Alright? Alright, let's use completing the square. Sometimes the formula is not so easy to remember it. Completing this. Although completing the square itself is difficult. Alright, so lambda squared minus 9 lambda minus 22 equals 0. Now we add half the coefficient of x squared. Half of 9 would be 9 over 2, which is 4.5, because keep it at 9 over 2. So it's minus half the coefficient of lambda squared, 9 over 2, and square it. Alright, so, let's put some more space here. Plus negative 9 over 2, because it's plus half the coefficient of x squared, half the coefficient of lambda squared. The coefficient of lambda is negative 9, not positive 9, you know. As remember, this is in the form lambda plus negative 9 lambda, right? So it is negative 9 that multiplies lambda. So half of negative 9, and we square that. We need to compensate. So we minus half of negative 9. 9 over 2, negative 9 over 2 squared. Alright? So we added it, we must subtract it back. So this part can be written as lambda minus 9 over 2 all squared. If you don't remember about completing the square, you can make a comment in the comment section, and I'll add some videos of what I did regarding completing the square. The note here, minus 22 minus 9 over 2 squared is 81 over 4. Alright? Equals 0. So lambda minus 9 over 2 all squared equal. Let's add these to both sides. It's going to be 81 over 4 plus 22. You could work it out as a fraction. Have my fraction calculator here. 81 over 4 plus 22 equal 169 over 4. So this would amount to 169 over 4. Alright? So if we find the square root of both sides, then lambda minus 9 over 2 equal positive and negative the square root of 169 over 4. Right? So lambda would be equal to 9 over 2 plus or minus the square root of 169, that's 13, over square root of 4 is 2. So one of our lambdas is 9 plus 13 over 2, and the other lambda is 9 minus 13 over 2. Alright? So 9 plus 13 is what? Let's write it over here. 9 and 13. So that's going to be 22 over 2. So 9 plus 13 is 9 plus 13 will be 22 over 2, which is what? 11. And the other lambda, call it lambda 1 and lambda 2 then. Lambda 1 equal that, lambda 2 equal that. So 9 minus 13 is negative 4 over 2 is negative 2. So there we get our lambdas, 11 and negative 2. Let's write them down up here. So Lambda 1 equals 11. Lambda 2 equals negative 2. Alright, so what else is going to happen now? We're going to find out what our vectors are. Alright? So here now, we know that the matrix minus lambda times I equals 0. But this time we're going to multiply by v to find the vectors. So let's erase some of the work that we did before, because we want to find out what the corresponding eigenvector is for each corresponding eigenvalue. So 4, 14, 3, 5. We have 4, 14, 3, 5 minus lambda times the unit matrix 1, 0, 0, 1 and the eigenvector times that minus that equals 0. When we multiply lambda by what is in the bracket, what we're going to have is lambda 0, 0, lambda. Alright? Usually the eigenvalue is represented by lambda. That seems to be standard and widely accepted by a lot of persons, so that's what we're using. So here now, the VO, we put in the other bracket here, so I like to put it. So here now, V times what's going to happen inside this bracket. 4 minus lambda, minus in the corresponding element. 14 minus 0 is 14. 3 minus 0 is 3. Then 5 minus lambda equals 0. Alright? Now, here, we're finding lambda 1. Lambda 1 equal, what was it again? Lambda 1 is 11. Lambda 1 is 11. What happened with that? Lambda 1 is 11. So what we have is 4 minus 11, 14, 3, 5 minus 11. Now remember, V is a column matrix 2 by 1. So if we have, for example, here x, y, we wouldn't be able to multiply it like this. So we need to have the V on the right, x, y. Alright? So that is equal to 0. So let's put it out. 4 minus 11 is what? 11, 12, 20, 50, 4 minus 11, negative 7 now. Negative 7. Then 14, 3, 5 minus 11, negative 6, and x, y equals 0. Continue erasing the previous work that we did. So here, what we're going to have is at negative 7, x plus 14 by 5. 5 4 is 20, we know only 0. Carry 2, 5, 1, 5, 6, 7, and a 70. Oh, my. You notice what happened? I wrote the y so bad that it looked like 5. It should be 5. Yeah, negative 7 by x plus 14 y. And then 3 by 14. 3 4 is 12. Bring down the 2, carry 1. 3 1 3 1 4. 42 minus 6y equals 0. Well, let's write it in a matrix form. This would be 40. This one. Oh, where did I get this from? My. Let's look at it. Negative 7 times x is negative 7x plus 14 by y. 14y equals 0. 3 by x. Why did I say 3 by 14? 3 by x. It would be 3x minus 6y equals 0. Right. Now, let's write it in an augmented matrix form. Augment into adjust and change and so on. Looked up the word augment. It means to make something greater or more intense, right? More numerous, whatever it is. But let's get rid of the x's. We know on the left column is x, and the right column is y. And instead of having 0, we have vertical line here. Instead of having equal, we have a vertical line here. And the zeros are to the right. And the plus and minus, we have the negative mirror to the 6. Alright, we have that matrix. What we want to do? Oh, by the way, let's get rid of these things too. What we want to do? Say we make a little change here. Let's say we have 1 over negative 7 times row 1 will give us the new row 1. This is row 1, this is row 2. So negative 7 over negative 7 is 1. 4 over negative 7 is 1. 14 over negative 7, negative 2. Oh, well, write it so near and close the bracket here. Let me redo this thing. Alright, so 1 over 7, negative 1 over 7, row 1 will give us our new row 1. 0 over negative 7 is 0. Then we put 1/3 row 2 to give us our new row 2. So 1/3 times 3 is 1. What is 1/3 of negative 6? Negative 6 over 3, which is negative 2, equals 0. Alright, as expected, the two rows are really the same thing. Now, what we have here therefore is 1x minus 2y equals 0. So it's x minus 2y equals 0 in both cases. We're going to find x and y. Now, x and y, there is no specific value for each. If we let x equal 1, then 1 minus 2y is 0. 1 is equal to 2y. So in this case, y would be half. See that? Suppose we had let x equal 2. What would happen? 2 minus 2y would be 0. Then 2 is equal to 2y. 2 minus 2y would be 0. 2 is equal to 2y. So y would be 1. So y would be 1. Suppose we had let x equal 3. What would happen? What would y be equal to? Y is 0. What would y be equal to? 3 minus 2y would be equal to 0. 3 is equal to 2y. So y would be equal to 3 over 2. Suppose we admit x equal 4. So we say let x equal 4. What would y be? 4 minus 2y would be 0. So 4 is equal to 2y. So y would be 2. Alright? So, as you see, whatever x is, y is half of it. Right? So we could have an eigenvector when x equal 1. When x equal 1, what we have is 1 half. 1 half. When x equal 2, we'd have 2, 1. When x equal 4, we'd have 4, 2, and so on. So 2, 1, we could use any one of these, you know. Well, let's use 2, 1. It's quite neat. No fractions are in it, and they are small numbers. So what happened? When with lambda 1 being 11, v1 equal to 1. So lambda 1 11, v1 2 1. Alright? So when lambda 1 is 11, v1 is 2 1. The vector 2 1. What happened when lambda 2 with lambda 2 negative 2? What would happen? We're dealing with lambda 2 now. Negative 2. We're going to have 4 minus negative 2, 5 minus negative 2. Right? Remember, it's 4 minus lambda. It's 4 minus negative 2, which is plus 2. 5 minus negative 2, which is 5 plus 2. So 4 and 2 would be 6. 5 and 2, 7. So that's what we'll have. The 3 and 4 would not be affected. So what we have is 6, 7 here. 3 and 4 remain. So here now, if we let's erase what we have over here. It might get things confusing if we keep them. So let's erase them. Alright, so here now, what would happen? If we have 6, 14, 3, 7, what you would get, if we want to simplify everything, 6, let's say 1/6 of row 1 will give us our new row 1. 1/6 of 6 is 1. 1/6 of 14. 14 over 6. 14 over 6 is the same as 2 into 14, 7 2 into 6, 3, 7 3. 7 over 3. And then 1/3 of row 2 give us our new row 2. 1/3 of 3 is 1. 1/3 of 7 is 7 over 3. See? Same thing. You would get the same rows. So, what they are saying is, remember, x is here and y is here. X plus 7 over 3y equals 0. So x plus 7 over 3y equals 0. Right? That's what it is saying. So therefore x is equal to negative 7/3 y. Now we could make x 1. Right? We could make x2, we could make x3, anything you want. But I have a feeling that if we make x3, we'll get some clean, neat numbers. Let x equal 3. What would happen? 3 is equal to negative 7 over 3y. Oh, hold on there. Let x equal 3. That would happen. Y would be 9 over 7. I don't want any fraction. Nothing wrong with fractions in there, you know. Right? I just like clean, pure whole numbers. Let x equal 7. What would happen? 7 equal negative 7 over 3y. Alright? So y would be what now? 7 times 3 equal negative 7y. So 21 equal negative 7y. So y would be 21 over negative 7, which is negative 3. So when x is 7, y would be negative 3. Alright. So v2 is negative 2. We have 7, negative 3. So it's negative 2, 7, negative 3. So v2 is 7, negative 3. Good. So we found the eigenvalues and the eigenvectors. The eigenvalue 11 corresponds with eigenvector 2, 1. Eigenvalue negative 2 corresponds with eigenvector 7, negative 3.